there. When you're standing there, it's not so bad. It was when you get forward that it was.
Okay, yeah, I actually able to use this most of the time. It's like... Okay. So we'll start this week's class, and let's see. Maybe let me make this announcement first. Okay. You will have one more homework assignment due next week. That's from chapter 4. That's what we'll talk about today, sensitivity analysis. We won't be able to go through many examples in today's lecture. And when you go home, I'd like you guys to, because the content you're going to learn today is not that easy and needs some memorizing. Okay. It's not like, it's very different from those modeling parts that once you understand how you analyze the problem, then you can do the model. This part you need to memorize some things. And you need to spend some time on the material. So when you go back, look at the material, review them again, and then look at the homework. Okay. And the other thing I want to talk about is case studies. Case studies are coming with one due at the same time next week. And that case study is from chapter 3. It's the modeling, the LP modeling. Okay. And one thing I need you to do immediately after today's class is get connected with your team members. Okay. Let me show you when you go to your Moodle, you should be able to. So here, go to next, which is this week's. Okay, so this week's Moodle, and go to here, case study 1, communication forum. If you click on it, you should be able to see. Oh, sorry, I logged in. So Caleb, you are in team number 1, right? You may notice there is a team member named dummy account. That's me. Okay. So I created this as a student account so I can see what's happening on the student side.
So you do very well. Case study since you're on our team.
Right. No. It's dummy. Dummy doesn't do anything. But when you log in, you would be able to see. Okay. For example, I logged in as a dummy account in this case, and that dummy account is in team number 1. So when you log in, you should be able to see here, case study 1 team, and if you are team 2, then only team 2 discussion will show here. And you click inside it, and then you can just start to communicate. That's one way to find out which team you are. So when you go back today, or you can even do it during the break, go to this forum. So it's called Case Study 1 Communication Forum in this week's content. Okay. Go there, you will find out which team you are in, and then just say hi there. Okay, I'm Shima. Oh no, Shima's not here. In the other, so I'm backup. Nice to meet you guys. And everyone just say hi, so you know who your team members are, and start communicating. And back to this here, get connected. Second, give your team a name. Give some meaningful or any name you want, but the appropriate names. Okay, so give your team a name, and later you will use this name for your team, all the team assignments throughout the semester. Okay, and make a presentation choice. So here, go back to Moodle again. Here, there is a choice. Here, make your case presentation choice because there are 4 cases. Chapter 3, chapter 3, 4, 5, and 6. One team will present one case. All the teams will perform case study analysis and turning a report for all 4 cases. But you only choose one case to give the presentations. Okay, so talk to your teammates and say, okay, which case you want to present, and then you make your choice. Okay, and once you make the choice, once you select the case, then that case will not be available for other teams to choose. And I already put the advantages, disadvantages here. So advantages for choosing, say like earlier cases would be they are easier, and you get something done, they're out of your way. And if you choose later, but disadvantages will be like you would be the first team testing the water. So maybe after you look at more presentations by the other teams, you know, oh, maybe we can improve in this, and other team may give you some ideas. So that's kind of like a disadvantage. You don't have any people before you presenting. But if you are pretty good at giving presentations and you know what to talk about, then just feel free to volunteer for earlier case. Okay, but you can. I think like my suggestion is based on your schedule. So which one works best? Okay. There's someone talking here. Okay. Okay. So that's about the team. And because case one is due next week, so I need one team to volunteer for this case one very soon. Okay. So because you have to choose a case, so if you are decided, okay, we're going to do this first case, then you get started earlier. Don't wait until the last team that everyone make the choice and the only case one is left for you team and you start to prepare it. That would be the worst case. Okay. And here, this thing is what I want to emphasize. Move all your main communication from emails to the Moodle forums. Okay, what did I mean? When you go to your Moodle again, okay, here is the case one communication forum. That's where I ask you guys to just go there, say hi to your team member. Every time, say like in the email, you want to say share some documents, say like you, okay, first communication, let's figure out the time to meet. Usually you send emails, right? Put them here. Just say, okay, let's figure out the time to meet. And then after you meet, so you decide on something, say, okay, Beckham is going to develop the model for this part, and Bashu is going to say write the introduction of the report, and who's going to that. You put the responsibility assigned in this forum too. Okay, kind of like a brief meeting summary. And then usually what you do will be you go maybe work on yourself and you have this part ready, right? And you send email to your teammates, say, okay, here is what I have, comments or like make suggestions things. Then you don't use emails, you just put them here. Because in the forum you are able to upload the files. Okay, so you just upload the files there and have those main communication there. If your main communication happens during those team meetings, maybe just briefly summarize like the responsibilities you assign and whether it's accomplished or not. Purpose of this is because eventually I'll ask you guys to evaluate your team members' contributions, and I also go there to check to see if everyone contributed to this project. I mean, to this case study, a fair version of it, a fair part of that. Okay. Okay. Because I've had the students before coming complaining, one of the teammates just didn't do anything. It will happen. It will too, right? So here you have some records. Okay. This part I did this, and that part we did. It does not have to be like everyone have to be okay. So 3-person team, right? Does not have to be everyone contribute 1/3 to the modeling and 1/3 to the writing, 1/3 to like the report presentation. As long as you distribute the job fairly among yourselves and you did the part that's assigned to you, then I'm fine with that. Okay. Okay. So that's for this communication. And follow the guidelines in developing your case study report. Again, that's in the report. And I got one example case study report from one of my previous students. I just got it this afternoon, and I'll upload it to it here. But to make sure you check this report guideline, I put it very clearly. Things you should do and things you should not do. Okay, I expect you to read this, really read this before you develop your report. because I've seen things that I put here, do not do this, and that's here, exactly on the report. Okay, so refrain from doing that. That's the guideline. And as I said, I'll put an example here so you can check out the example. So that's the announcement I want to make. Okay. Then what we're going to do now is to finish this LP model that's left from last time. That's from chapter 3. And we'll talk about sensitivity analysis. Okay. So let's read this problem first. Or if you still have the printout from last time, from week 2, it should be the last one. Reading first, figure out what this company is trying to do. Okay. Don't worry about the decision variables of JP function and constraint. Yes. Just figure out what is this company trying to do.
They're trying
okay, kind of like a fundraising. Okay.
But they're trying to minimize the amount of investment that they need to put in these different instruments to meet their obligation, which is $250,000 at the end of the second and fourth months, and a final payment of $300 million.
Okay. So she must said the kind of like a fundraising for what?
Construction. They want to build a company like in different locations.
Okay. So they need to fundraise so they can pay for this, right? Okay. And Becca said they want to minimize the amount of money that probably they invest in those funds, so that they can just meet those payments. How many payments?
There's 3 payments.
250 at the end of the second and the fourth month, right? And the final payment. So that total is 800,000. Okay. And these are the investment options. And different from that investment problem that we talked about last time. This time, they can reinvest in a fund when those investments mature. Okay. For example, investment A is available in every month, and it matures in every month too. So you invest at the beginning of this month, you get the principal plus 1.8% of the interest. Okay, at the end of this month. Then with this much of money, you can reinvest in A again because it's available immediately again. Okay, similar to B. B matures every 2 months. Okay, so when you say you invest $100 to B at the beginning of first month. After 2 months, that will bring us to the end of the second month. Okay, you get $103.50. Okay, and with this $103.50, you can reinvest in B because B is available right away. That's the beginning of the third month. Okay, but of course, this money you can invest in A too because A is available here too. Okay, and C is available month 1 and month 4. D only you can invest just once because the time frame is 6 months. Did they say it here? Yeah, 6 months. Okay, so the planning horizon is 6 months. Okay, and this table and the maturity rate and the months to maturity, we already talked about what do they mean, and we'll talk about what this company is trying to do. Okay, let's just let me go to the next. We'll just do those simple analysis. So let's see that. Okay, months. Beginning of month 1, 2, 3, 4, 5, 6, 7, and the end. Beginning of month 1, end of month 1. Okay. So here I use the beginning of month and end of month just to put those both numbers here so it's clearer to us. Okay. 1, 2, 3, 4, 5, 6. So these are all the months that we are considering. And based on our analysis, we just put, okay, for example, if we put $100 in A at the beginning of month 1, say 100. Here I will say that's the, we'll just say like the cash outflow, okay? Because that's like how much money we take out. So these will be cash. Say if we put $100 here, cash inflow. Then how much do we get? We get here, right? If we put $100 here in A, okay. Then how much do we get at the end of 118, right? And now we don't know how much to put in A at the first month, right? That's something we're trying to decide.
No, that's 18%.
Yeah, so that's, oh, sorry. Here. Here, thank you. Okay. So, but the problem is that we don't know how much we're going to put right now. So that's what we're going to decide. So that translates into our decision variable, right? So how much to put in A in the first month, that's one of our decision variable, right? So let me just use, say A. And it's the beginning of the first month, so I just put A1. Okay, so that's the amount of money I'm going to put in A1. And I know that how much I will get. Yes, 101. So that's how much, oh, and A1. That's how much I will get from A1, right?
1.8.
Okay.
It's not 1.018. It's 1.80. But yeah, but we get the point.
Okay, I'll just put the percentage.
1.8.
Well, oh, that's what I'm trying to put. There. Okay. So then we know that you can put in A again, right? At the second month, but we just don't know how much we're going to put. I just put here as A2 and same thing. A2. Okay. Then we can do the same for A in all the months. Oh, sorry, A6. And then we're not going to invest here because it's the end of month 6 already. Okay. And here will be 1.8%. 3. Okay, these are all the return, investment and the returns from A. Okay. Then we'll look at B. Same. So B is available in months 1, 3, and 5. So we can have B. So will be B1, B3, and B5. Okay, that's when we can invest. And those BI represent the amount of money we put in B in the I months. Okay, and so for the amount of money we put in B1, it matures here, and it's 103.5. B1 because the yield rate is 3.5%. Am I right this time? Okay, so B3 it will mature here. B5 will mature. Okay, then you can do that for C and D, right? C is available first month and the fourth month. And wherever it's available for investment, you get the yield plus principal from the previous investment. So C1 matures fourth month. Okay, and the rate is 5.8%. So 1.8% and here 1.1. Oh, sorry, C4. Then D, you only invest it one time, right? And you get 11%. So that's 111% times E1. So this is the table analysis of all the possible investment and their return. Okay. Then, for the cash outflows, besides those ones, okay. Besides those ones, remember our purpose is that we can make those payments. Okay. So we have to make this payment 250,000 at the end of second and fourth month, and the final payment 300,000 when it's complete, which means 300,000. And we have to make the the payment of 250,000 at the end of second month. So at the end of second month, that's 250,000. And at the end of the fourth month. Okay. So these are payments that we have to make. this summarizes all the cash flows. Okay, and we said what the company trying to do is that they are able to make these 3 payments with investments by investing some money in those different investment options, and so that, for example, here, let's just look at the first payment. Yeah.
Your second payment is supposed to be for 250, 250, and 300.
Oh yeah, this is 250. Sorry, that should be 250. Yeah. I was trying to use the. Okay. 250. Okay. So let's look at just this first payment. So where does the money come from to pay this 250,000? From here, right? Those 2 are the only cash flows. So to make this payment, money comes from here plus this one minus if you are going to make more investment in A3 and B3. Okay. Then same here. This 250,000 money comes from that. What do you get out from here? Here. Can you see this little point? Okay. I'll just highlight it. So to make this 250,000, money comes from this one plus this one.
What about the previous ones?
Minus these 2.
What about the previous period?
What about these ones?
Yeah.
We'll talk about that later. Okay, so we'll look at the payment first. Okay, then for example, this last one, money comes from this plus this one plus this one plus this one. Okay, so for these 3 payments, as long as the money that we got from those investment returns subtract what we're going to take out for new investments is available to meet those payment requirements, then we are fine. Okay. Then what about in the months that we don't have payment? For example, this second month, what's the relationship between these 2? What's the relationship between these 2? You can just think of this being payment of 0, right? So you don't have to pay anything, but what you get out from this 101.8% times A1, you should have enough to make investment in A2. Okay, similar to here. So it's just 0 payment, 0 payment, right? So as long as what you got from these 2 investments is enough for you to make reinvestment in A and C, then you are fine. Here, as long as what you get from this A5 investment return can cover what you're going to pay, reinvest in A6, then you are fine. Okay. Then what about in the first month? What happens at the beginning of first month? Where does those money come from? From what? From the restaurant, right?
Yeah.
Okay. So what are those money? Those are the really out-of-pocket money, right? So when Beckham said we're trying to minimize investment in those investment options to meet those payments requirements, we're really talking about these 4. Okay, because one mistake people tend to make is when they write the objective function, they put minimize the sum of all of those investments because they view those as these are all cash outflows. So they want to minimize, okay, the total investments. But in doing that, you're double counting the money is still out of pocket. Because where does this A2 money come from? From A1, right? And where does this A3 come from? From A1, and again, A2 is from A1 and from B1. So if you add all of them together, when you minimize the total investment, then you count the out-of-pocket money several times. Okay, so what we're trying to do is just to minimize what we take out now. Okay, which is this one. Total. So these are the total out of pocket money, and we want to just minimize this portion. And what we talk about regarding the relationships of the cash outflows and inflows in each month will be our constraints. We just want to make sure that the cash inflows in a certain month should be able to cover the cash outflows in that month. Okay. Okay. So with that analysis, I'll just work on this with this spring arming. So we'll use this. So we'll just use this as the reference, or it's too small for you guys to see. Okay, so I duplicated this slide here. So on this slide, okay, so I deleted that part and erase those. Don't go. No, they won't go. Okay, we'll just use those as separation. Okay, so our decision variables will be AI, where I goes from 1 to 6. Equals to be 1, 3, and 5, right? C, K equals to be 1 and 4. And E1 represents the amount of dollars goods in investment A, B, C, D. That's the definition of our decision variables, and our objective function will be to minimize just A1 plus B1 plus C1 plus B1. Okay. Then the constraint will be easy. Subject to this works. It doesn't work. I plan to just erase the border of the table. Then we can just write. Okay. So let's just do this. So first constraint would be so first constraint would be A2 need to be less than equal to 101.8% times A1. Okay, we put less than equal to because the company may want to set apart some money. We talk about this. If the company is going to use all the money to invest, then it's the same as putting an equal sign. Okay, but make it less restrictive, so the company may be putting aside some money. Okay, and then here, second constraint, let's plus this one plus 250,000 need to be less than equal to this plus this. Okay, then A4 plus B4 need to be less than equal to 101.8% plus this one. Plus less than equal to A6 less than equal to this part. And the last will be 300,000 need to be less than equal to all of those right parts. So we have one constraint, two constraint, three constraint, 4, 5, 6 constraint plus AI, EJ, all be greater than equal to 0 for all I that goes from 1 to 6. J goes from 1 to 5. K goes from K equals to 1 and 4 and equals to 1.
Last one is 300,000.
I just issued 300,000 less than equal to all those cash outflows. Oh, sorry, cash inflows. Move to that. So on the slide, I put the definition of the ABCD, use I as just a subscript. So minimize the total cash invested in month 1, representing the total out of pocket. Okay, and then in each month, on this slide, I moved all the right hand side to the left and use the equal sign. But using greater than equal to will be better. Okay. So this represents an example that some of the problems before you start to think about, okay, what's the decision variable? Maybe analyze the problem first. For example, in the transportation problem, we draw some graphs, right, representing the the shipping from node and the shipping to node, supplies and the demand. Okay, and after that, we start to figure out, okay, what are the decision variables? In this case, we have this whole table analyzed. Then we look at the relationships between the cash inflows, outflows, trying to see what this company is trying to do. And then we have this entire model figured out. Okay, so the problems work differently. Sometimes you can identify the decision variables and the objective very quickly, just from, say, from most of the problems we talk about so far, from the last sentence of the problem statement, right? But in this case, we figured out the entire model together by analyzing this and summarize them in the table. Okay. There is one problem that I plan to talk about in chapter 3, but we don't have time. And I'll put the class lecture video on the Moodle so you can watch it. And that's closely related to one of the homework assignments that you're going to do, which is to be analyzed the same way. So you have to analyze the problem first before you figure out, okay, what the decision variables should be. Okay, and then you will have the model. Okay, so that's for this problem. Or implement this, you will have time. Okay, so we're going to move on to chapter 4. So this is the part that I said you need to get ready if you feel sleepy. Because a lot of information is going to be presented. Okay, so using that blue ridge hot top problem, the very first example we talk about in this class, we implement the model, solve that, and we got the solver solution. Okay. Based on this Excel spreadsheet, what are you going to suggest to the manager at the Blue Ridge Hot Top company? You guys still remember the problem?
Yeah.
What's the suggestion to them? Okay. Okay.
66 labor.
Okay, so make 122 aqueous bus and 78 hydrolysis, right? So that's the suggestion. And what is the suggestion based on? All of those information here, right? The unit profits of aqueous bus should remain to be 350, and hydrolysis should remain to be 300. Same as the labor constraint, pump constraint, tubing constraint. Okay, and if you work in the company, only give this, okay, we should make this many to the manager. Probably that's not a good enough report. Okay, managers always want to know what if. Okay, so then when, okay, the unit profit, say if we are going to, are we able to say increase the profit a little bit because the market is really good recently. For sure, if we increase the profit, we're still going to sell the same amount. I mean, sell all of them. So, what should the new decision? Do we make the same numbers of each type, or those numbers should be changed? Okay. Or say this company is trying to implement some improvements to their manufacturing, and so they implement the lean manufacturing and save some resources, and say the labor part gets really increased, so they now use less labor. Okay, so what does that mean to this decision? Are they going to make the same amount? Okay, or say, okay, they found, oh, we didn't count some of the extra labor available. Here, the labor is really one of the constraints that prevents the solution to improve, right? So, if we have more labor, should we make the same amount as you suggested? Okay, so those are all the questions that the management would like to know. Okay, and what do? You go to, okay, solve it again when the question comes, or can you prepare a comprehensive report giving all those different scenarios to the manager. Say, okay, here are the range. Say, okay, for the hydrolysis, as long as your profits is between 250 to 350, you're going to make the this many aqueous spots and hydrolysis. Number one change. Okay. And here are those available of the resources. As long as those resources change within this range, our profit will still be the same, but the number to make probably will change. Okay, so that's what the sensitivity analysis is going to tell you. And when as we said, when solving LP models, we assume that all the values associated with those coefficients, they remain to be the same, and they are known with certainty. But such certainty never exists, and things are always changing. Sensitivity analysis will help ask questions, say like, okay, how sensitive the current optimal solution is to changes to those various coefficients in the model. Okay, and remember we said this is the general format of a LT model. Okay. So the objective function with those coefficients as we see, and the constraints, left-hand side constraints coefficient A, and right-hand side with B represent. Okay. We're going to study how sensitive is the solution, which means the x1, x2 value. Okay. And we'll look at also how sensitive the objective function value will change when changes to C, A, B happen. Okay. So some approaches to sensitivity analysis are that just change those coefficients and resolve it again, rerun the solver. That's one way. Sometimes it's the only practical way to do it, especially if you want to know a certain scenario in which multiple coefficients change. Okay, sensitivity analysis report is very powerful, but not that powerful. That tells you everything. Okay, but another way is to do the graphical analysis, like in chapter 2, we talk about how those changes. Okay, we'll mention that. And by using the graphical analysis, we'll be able to see how the physical region change, how the level curve change, how the optimal solution change. So that's one way. But with that, it only works with how many decision variables? Graphical solution. 2 variables. Okay. I'm going to start to ask someone to answer the question, so you guys need to pay attention. Okay, third, mathematical deduction. Because the A, B, C's are all related, and we know that how the optimal, just think of that, like for example, the level curve is decided by what? Level curve slope. What decides the level curve? What value? The objective function values, objective functions coefficients, right? So for that part, we should be able to calculate using mathematical deduction how much those values can change without changing the optimal solution. And fortunately, we don't have to do that by hand because solver produced this sensitivity analysis report for us. Okay, once again, we'll use this example. I have this model already opened here. Okay, so that's the model that we implemented in solver. So you probably have noticed then when you go to solve the problem, you read this message and say, oh, click OK. And on the right hand side, there are some reports that you can look. Okay. You just click on all of them. Click OK. Then you will see all of the reports got generated for this model. Okay. And one thing I want to notice that, let's click on one of them. You see that in this model, in this sensitivity report, the name of the cell, for example, C13. Okay. C13. Just this one. Okay. That's our objective function. Remember that? Okay. It says, okay, the name is total profit. It put equals plus here. That's because the row label is total profit and the column label is to this equals plus here, which is not very accurate in the sensitivity report, but we know that we know this is the total profit part. Okay, and for example here, this one is pretty meaningful here. Number to make equals plus 122. Okay, and that came from here. So number to make equals plus. So when sensitivity analysis report is generated, it automatically take the row number, the row label and the column label, put them together to be the name of that specific cell. That's an indication of the importance of having meaningful label for all your cells, especially consider the column and the row, because a sensitivity report with those names is much easier for you to interpret it. Okay, if your name will be like X1 to just some like a number to make, then you don't know which one is which, or even just say like say equals plus hydrolysis. It's not very meaningful. Okay, so that's just one point that I want to point out, especially in the homework assignment too. That's going to be due next week. Those problems are, say you need to first formulate the problem. Okay, maybe many of the business problem, and then you interpret the sensitivity analysis report by answering. Okay, say if the resource of labor increase that many, what does that mean? So you need to find, okay, which cell represents that labor of the labor resource part. If you don't have meaningful labor for your cells in the Excel model, it will be very difficult for you to find out which is which. Okay, so that's very important. Now let's look at how to interpret those. First, we generated 3 reports. The first one generated is the answer report. So this one does not give much information. It gives like, okay, what's the total profit and what's the final value of your decision variables. Okay, and for the constraints, only thing I want to notice is the constraint part. Okay, I'll ask you guys to look at this column and this column. Now tell me, what do you see here? What's the relationship between the status and the slack? Later. I know you took it before. Let them think first. Look at this.
Because they used all the available amounts, so they have the binding constant.
Okay, which one used all of them?
The pumps and the labor.
Right, labor, pump and labor. Remember, those 2 resources are all used up, right? And the tubing is not used up. Okay, so you can see that the 2, and we remember that the graphical solution is here, right? And that's where the pump and the labor intersect. Okay, so these 2 constraints, they are binding, and they have slack of 0. Okay, and this slack means no more left, as it tells by the name, right? No more left, no slack. And this tubing part is not binding because it has 168 left. Let's go back to the here, tubing. What's the difference between these 2? 168. Okay, so that's what this slack is. Okay, so what is slack? Slack equals to be the difference between output absolute value, left hand side value, subtract right hand side value. Okay, so that's the slack, and binding constraint. So binding constraint always have zero slack, and the non-binding slack is always it's not zero. It's always not zero. Okay, so that's what I want to talk about for this answer report. Just pointing out if it's a binding constraint, then the slack. Okay, then this part is what we're going to focus on for this. Do you guys want a break?
Yes.
No? Okay, so maybe we'll talk about a few parts and then we will take a pause. Now it's 3. We'll go for maybe, we'll finish the first part of it, then we'll take a break. Okay. And if I'm going too fast at any point you have questions, please feel free to ask. Okay. Okay, so this sensitivity analysis report we're going to look at. So this first part is the same as the answer report. It just tells you like what's the objective function value. Okay, so then we'll look at this adjustable cell part and the constraint part. So what it answers, the questions that sensitivity analysis report answers: the amount by which the objective function coefficient can change without changing the optimal solution, which means the x1, x2 values. Okay. The impact on optimal objective function value of changes in constrained resources. So as I said, if say we have more labor, if we have more tubing, if we have more what's that other pumps, what the impact will be on our objective function value. Okay, that's the total profit. It's not the x1, x2 value. That's something to differentiate. Third, impact on the optimal objective function value of forced changes in decision variables. Say a decision variable result is 0. Say in the Blue Ridge hot tub, if one of them is 0, that means we're not going to produce any of that hot tub. What if the company says, okay, just for strategic reason, we want to produce this, even though it's not going to make more money for us. We just want to develop this new product. How much impact will that on our total profit? Sensitivity analysis will tell you. And impact changes in constraint coefficients will have on optimal solution. Okay, so we'll talk about the first one, objective function coefficients. So if we look at the graphical solution, okay, we said that the objective function coefficient is related to the slope of this level curve, right? Okay, and currently this is the current optimal solution, okay, and that's because of this slope. If the slope changes to like this, then optimal solution is going to point. This bottom column points, right? Okay. And or if the slope is really flat, something like this. This is too flat, sorry. If it's really flat, like this, then this point will be the optimal solution. We have to move to this direction. Okay. So you know that, so you see that this slope, which is determined by the coefficient, really determines which point is the optimal solution. And from this point to this point, there is some space for it to change. Okay. So let me go to this graphical representation. Sorry, those arrows to really lock in some of those values here. So this should be, that should be 350. I just change it here. Okay, so originally it's 350 and the 350. It worked on my old version of Excel, but I opened this new Excel. Those it's not even let me. I think 350, right? Okay, and I could not reset it. Yeah, this is already 300. That's the original. Right? Is that right? 350 and the 300, right? 350 and the 300. Okay. So, originally, this is the point. Okay. So let's see. Oh, this is not moving. This line is not moving. Okay, it's not moving. So originally I have this line moving. It's not working on this computer. Let's just go back to just use this one. I want to show you in a more dynamic way. Let's see.
It was moving.
The line, is that moving?
It was moving.
Oh.
It was going to go awesome.
Oh, did it? Okay, that's good. Is it moving? Oh,
Yes.
good. Okay. Okay, so that line is moving. Okay. Has a little time lag. I didn't notice. Okay, so let's see. Oh, already moved. When did it move? So if you can look at this green point, which is the optimal solution. Let's go back again. See when did this move? Okay, from 340 to 345 didn't move. 350. We're at, yeah, you can see here that's a 410 now. Okay. You can see this low diff. Okay, just cross that. I want to see that too. Wait, let me go back to the point. I don't know that too. That's a 440. I'll just put a 440. 450. Okay. So when you change from 350 to 450, the optimal solution changed from this one point to this entire line. And we talk about that, that's alternative solution, right? And if you change it to one more point, 451, then the optimal solution changed to here. And you see that we changed it from all the way from 350 to 450 until this point and the entire line becomes the optimal solution. Okay, that means there is a range, which is how much? 350 to 450, 100. So that's this allowable increase of 100 units that this coefficient can increase without changing our optimal solution. Okay, And it's the same for this part and want to do it here. So you use this slide to illustrate that. So that's what we have, the original objective function, and the optimal solution is here, and this blue dotted line is the level curve. And when we change it this way, this time I change this x2 value from 300 to 200. It also gets changed to this point, so the optimal solution changed. Okay. So if we look at that, just now this is 100 and this is 100. Okay. So the values in the allowable increase and allowable decrease column for the changing cells indicate the amount by which an objective function coefficient can change without changing the optimal solution. Remember, optimal solution means that point. Okay, it's the decision variables value. It's not the objective function value. Okay, it's the decision variables value. Think about that. Let me ask you, will the objective function value change?
Yes.
Why?
Because the objective function is a function of the point that we're looking for.
Okay.
So as you're moving, when the constant change,
Okay. Okay.
the value of the objective function.
Okay. Okay. So the objective function value is a function of those decision variables, which want to change in this case, and their coefficients, right? And since the coefficients change, objective function value will change for sure. Okay. Some common mistake students make before that they say, okay, that's the allowable increase decrease for the objective function value, and the solution to remain to be the same. It's not right because your coefficient changed. How come your objective function value does not change? Okay, it's only about the optimal solution, which means the decision variable values. Okay, so let's look at. Let's go back to. I don't know whether you guys printed out that one page. I asked you. So one thing you can do is use that one page to take notes. Similar as mine here. Okay, so that's right here. Okay, so what do we talk about this here? So the adjustable cells represent those, the first one we're looking at, those ones. Okay, so the allowable increase and allowable decrease in the adjustable cells represent the amount by which those coefficients. So you can read this table as these are the allowable increase decrease of. Okay, the allowable increase and decrease of the objective function coefficients. Okay, for here of them. For these ones to remain the same. Okay. These two columns are the allowable increase decrease of the coefficient, objective function coefficient. In order for the decision variable values to remain to be the same. Okay, so if you remember in this way, it's u. What do these values represent? Okay, and then a special case. A 0 here means, okay, think about the graphical solution. In terms of, okay, what happens if there is a 0 here? What does that mean? when there is 0 here, means just 1 unit of change. The solution will change. Okay, so if you remember, what happened here? 450. So at this point, you have alternatives because like all the points on this line are solutions, right? Just 1 unit of change on either direction. Say, okay, now it's 450. If we change it to 449, the solution becomes this top point, right? Or if we change it to be 451, solution becomes this bottom point. What does that mean? When this objective function coefficient is at 450, the allowable increase or decrease of this coefficient is 0, because just 1 more unit of change will change your solution from all the points to this point or this point. Okay, so a 0 here indicates that currently you have alternative solutions. A 0 means if we represent it graphically, all the solutions on this point, on this line, are the solution. Okay, and just 1 unit of change will become this point or this point. Is this part clear? Okay. Now we go back to here. Okay, means alternate solution exists. Okay, so any 0 here means alternate solution exists. So that's what this here slide means. Okay, and what we talked about earlier is only for 1 change in the coefficient. Okay, like for the 350 and the 300, only 1 of them change, and the log increase decrease is only applied in like just 1 change, and the other remain to be the same. Okay, because think about that, if you change both, then slope you may not know what happened to the slope. Okay, but there is a 100% rule to use if you want to determine whether the optimal solution will change when you change coefficients simultaneously. Okay, and there are 2 cases. Case 1, all variables with changed objective coefficients have non-zero reduced cost, or case 2 is with 1-0 cost. But both, we'll look at this first case. First case, if all variables with changed coefficients have non-zero reduced cost. We'll talk about reduced cost later. There is a place to define the reduced cost. Okay, the current solution remain optimal if those changes are within the allowable increase or decrease. Okay, so that's an easy case. But the second case, if at least 1 variable with changed objective coefficient has a reduced cost of 0, then you look at the percentage of the change the percentage of the change in regard to that allowable increase or decrease, and you add them together. If the sum is less than or equal to 1, then you are sure that the optimal solution won't change. Otherwise, it's not guaranteed. It may still not change, but it's not guaranteed. Okay, I'll illustrate this here. So let's go back to our notes. So for simultaneous change, for example, now the original objective function is this. Okay, and now we're going to change this one to be 340 x1 plus So this is simultaneous change, and we're going to use that 100% rule. And that 100% rule is to look at, okay, how much change has occurred. So this one, from 50 to 350 to 340, we decreased 10 units. Okay, so that's the amount of change divided by allowable decrease plus that's amount of change. In this case, we increased 10 units. So after this, increase. So it equals to be the 10 divided by, because the first case is a decrease, so we need to look at the allowable decrease of this coefficient. Okay, so allowable decrease is here, 50. Okay, divided by 50 plus, happen to be 50. In this case, it's allowable it's an increase, so it's a 10 units divided by allowable increase. In this case, we need to look at the increase. Okay, that's again 50. Okay, which is less than 100%. So solution won't change. Okay, so that's 100% rule. Just make sure you identify whether the change is an increase or it's a decrease. Okay, if it's an increase, make sure you get that allowable increase value to be the denominator. If it's a decrease, then get allowable decrease to be the denominator. Okay, and then we use absolute value. Yes?
So, what do you mean by solution will not change?
X1, X2 value won't change.
Mean only the variables?
Right. That's what solution means, right? Solution means the decision variable values.
But I mean what does that mean? Like allowable increase or decrease? That's from 350 the profit it becomes from 350 to like 500.
Okay.
So it means like the allowable increase
To 500, it will change for sure.
Which one will change? The optimal solution?
Optimal solution, yeah.
But the x1, x2 will be same.
What is optimal solution?
Even
What do you, when you solve the problem, what's the optimal solution include?
Got it. X1 the value.
The X value, right? Okay, that's something
So
I
it's
said
actually the
need to differentiate. The solution is the decision variable value. From the decision variable value, you calculate the objective function value, right? That's kind of like the objective. But the solution is like what you try to suggest, how to solve the problem, right? The solution, how to solve the problem, make this many of type 1, type 2. And the objective function value is that the goal that you want to change, that you want to achieve. Okay, that's not the solution, right? Okay, so remember, solution is the decision variable value. Okay, so that's about this table. Okay, so let's take a 10-minute break.
You can teach us how to draw that feasible reason and everything diagram in the Excel. Like the
yeah,
one
hold on.
you draw
Hold on.
here.
Let me stop this one.